Welcome to the last video on applications of vectors. We're going to look at work done on an object in this video. The work W, done by a force F, in moving along a vector D, is W equals F dot D. How much work is done if a man pulls a wagon from point P at -1,5 to point Q at 8,2 by applying 20 pounds on the handle that makes a 60-degree angle with the horizon? Displacement is in feet. You might be asking yourself, I have no idea how to even start this. But let's draw a picture first, and I think that will help. Also, since we're looking at feet and force in pounds, work will be done in foot-pounds when we finally find the answer. First, we know that there's a wagon. And it starts at point P, and that coordinate point is the point -1,5. And I know it goes along until it gets to Q, and Q is the point 8,2. If I wanted to, I could draw a vector between these 2 points that would represent the displacement of the wagon. And you may recall the formula for displacement: x sub 2 minus x sub 1, comma, y sub 2 minus y sub 1. Which means my displacement vector will be 8 minus -1, comma, 2 minus 5, which simplifies further to 9, comma, -3. That is my displacement vector. Now I need to draw the guy pulling the wagon. We know that he is pulling the wagon by this displacement, and his angle for force on the handle is 60 degrees with the horizon. So we can talk about force as being the components in the x direction and the y direction. So we have 20 pounds of force, or the magnitude, cosine of 60 degrees, comma, 20 sine of 60 degrees, which will give me the components 20 times 1/2, comma, 20 times √3/2. And that simplifies to 10, comma, 10√3. If I want to find the work done, I simply find the dot product of the displacement vector and the force vector, which will be 9, comma, -3 dotted with 10, comma, 10√3. And that will give me 90 plus -30√3, which is approximately 38 foot-pounds.